So, molecular formula. Molecular formula is the actual number, okay, actual number of atom of each element in a molecule. So, dia adalah actual number. For example, C2H4. So, from C2H4, you can draw this one. So, this is how C2H4 look like. So, it show the exact number. So, we have 2 carbon, 4 hydrogen. So, that is molecular formula. Empirical formula is a chemical formula that shows the simplest ratio of atoms of element present in a compound. So when you have C2H4, that is molecular formula. So the simplest ratio is CH2. So 2 bahagi dengan 2, 4 bahagi dengan 2 lah. So this is the simplest ratio. Okay, kalau tengok contoh dekat sini, C6H12O6. So this is the molecular formula. You can divide with 6, so you get this empirical formula. Okay, similar to the next example. Okay, so molecular formula show the real number, the actual number. Empirical formula show the simplest number, simplest ratio. Okay, for that chemical formula. Okay, but then molecular formula can be the same with empirical. Okay, ada masa molecular formula sama dengan empirical so tak ada masalah. Boleh sama. Okay, boleh sama, tak ada masalah. Okay, so if you want to determine molecular formula, you need to have empirical formula first. Okay, so from empirical formula, we can find molecular formula. Okay, using this formula. Okay, so this is example from mass composition. Okay, this is not combustion analysis. So this is example come from mass composition. Okay, so during physical activity, lactic acid with the molar mass 90.08 gram per mole formed in muscle tissue and is responsible for muscle soreness. Okay, elemental analysis shows that it contains 40% mass of carbon, 6.7% hydrogen, 53.3% mass of oxygen. So mass here is given in percentage. So we can use this one. Okay, no need to do anything. So mass dekat sini walaupun dia bagi dalam bentuk percentage, kita boleh ambil saja. So kita assume dia sama dengan gram lah. Okay, the first question asks you to determine empirical formula of lactic acid. So 40 gram, 40% is equivalent to 40 gram, 6.7, 53.3. Okay, and then divide by molar mass of carbon, hydrogen and oxygen. So you get number of mole. And then by referring to the number of mole, so this is the smallest value. So you need to divide this value with the smallest number of moles. So divide with this value. So we get 1 here, and then here is 2.012. So this one we can round off to 2. Okay, so the empirical formula is CH2O. Okay, so next if you want to find molecular formula, so dah dapat empirical, so you can find molecular formula. So molar mass is given in the question. So this is the molar mass. Molar mass is given in the question. Divide with mass of empirical formula. In mass of empirical formula is referring to this one. So 12 plus with 2 plus with 16. So it's equivalent to 30. So divide, you get 3 and equals to 3. This one must be round number. Okay, this one must be integer, positive integer. Dia mesti positif tak boleh dapat negatif dan tak boleh dapat decimal places. Kalau dapat decimal places ataupun fraction, something wrong somewhere with your calculation. Okay, so dia tak boleh, dia mesti dapat integer number and positive. Okay, so 3 times with 1, so you get 3. 3 times with 2, you get 6. 3 times with 1, you get 3. Okay. And then make sure please, bila tulis empirical ataupun molecular formula, kita tulis dalam bentuk macam ni. Maksudnya C besar, number 3 is quite small down there. H besar, number C is quite small. O besar, number 3 is quite small down there. Okay, jangan sama level pula macam ni. Salah this is the standard way to write down molecular formula. Okay, this is wrong. This is right. Okay, moving on to next example. Okay. So you have ascorbic acid. Okay, inside the ascorbic acid compose, okay, ataupun consist of, compose mean like consist of carbon 40.92%, hydrogen 4.58%, and oxygen 54.5%. So these are the masses of carbon, hydrogen and oxygen. Okay, so and then you find mole, divide by molar mass. So this is the number of mole, and then take the smallest number of mole, which is this one. So this number divided by this one, you get 1. This number divided by this one, you get 1.344. This number divided by the same number, you get 1. So 1.314 cannot round off. You cannot round off 1.344. Cannot. So what you need to do is, you need to transform this number into an integer. So how to do that? Okay, you cannot round off 1.3. Okay, you need to transform that number into an integer. So macam mana nak transform? Try and error. Okay, cuba 1.344 ni darab dengan 2. 1.344 darab dengan 2 dapat 2.68. Okay, tak boleh guna nombor ni. So 1.33 darab dengan 3. So bila darab dengan 3, awak dapat 4.032. So bila awak ada 4.0, so kita boleh round off. Okay, macam mana nak round off? Okay, ni cara nak round off. Kalau awak dapat 1.01, kalau awak dapat 1.01, kita boleh round off jadi 1 lah. Kalau dapat 1.1 pun kita boleh round off jadi 1. 1.1 kita boleh round off juga jadi 1. Okay. Tapi kalau awak dapat kat belakang tu 1.2, 1.3 until 1.8, you cannot round off. Please. You can never round off that number. Please you cannot round off that number. Okay. Kalau awak dapat 1.9, boleh round off. Kalau 9, boleh round off. Kepada 2 lah. So 0.2, 0.34 until 0.8 tak boleh round off. So macam mana nak jadikan dia integer? Try and error. Times with 2, times with 3. But kalau this one you times with 3, so this one you also need to times with 3. Okay, so 1 times with 3 is 3. 1 times with 3 is 3. So your empirical formula is C3H4O3. Okay, so similar like previous example, if you want to find molecular formula, molar mass divided by mass of empirical. So molar mass is given here, 176 gram per mole, divided by this mass, 3 times with 12 plus 4 times with 3, 16. Okay, so n is equal to 2, and again, n must be positive integer. So 2 times with 3, you get 6. 2 times with 4, you get 8. 2 times with 3, you get 6. Okay, so moving on to next example. So this example is example for combustion analysis ataupun combustion data. Kalau yang ni, dia bagi mass tau. Ni kita panggil example from mass composition. Dia dah bagi mass. So this one adalah cerita pasal combustion. You combust something. Say combustion of a hydrocarbon produces 1.83 gram of carbon dioxide. And 0.901 gram of water. Determine the empirical formula of the hydrocarbon. Okay, first and foremost, you need to know what is hydrocarbon. Hydrocarbon is the molecule that contain only carbon and hydrogen. So, dia hanya ada carbon dengan hydrogen. So, from the question, you don't have mass of carbon, you don't have mass of hydrogen. What you do have is mass of carbon dioxide and mass of water. Daripada soalan, awak tak ada mass of carbon, tak ada mass of hydrogen. Awak ada mass of carbon dioxide. Okay, so how to find mass of carbon from carbon dioxide? So, dalam carbon dioxide, awak ada satu carbon. Okay, so 12. Okay, ni mass of carbon lah. Divide by molar mass of carbon dioxide. So, 44 ni dia adalah molar mass carbon dioxide. Okay, macam mana cari molar mass dia? 12 plus with 2 times with 16. So, you will get 24. So, 12 is mass of carbon. Divide by 44. Timeskan dengan mass of carbon dioxide. Ni adalah mass of carbon dioxide. So, awak akan dapat mass carbon. Okay. Mass hydrogen is determined by water. Okay, from mass of water, you can determine mass of hydrogen. So, tapi kat sini beza dia adalah hydrogen ada 2. So, sebab tu 2 kali 1. 2 times 1. Okay, mass of hydrogen 1 kan. So, 2 times with mass of hydrogen. Okay, so ada 2 kat sini. So, divide by 18 is molar mass lah. This one adalah molar mass H2O. Okay, oksigen kan 16 tambah dengan 2 dapat dah 18. Okay. So, times with mass of water. So, this one adalah mass of water. Okay, mass of water. So, you will get mass of hydrogen. So, this is the only way to determine mass of carbon and mass of hydrogen. Mass of carbon is determined by mass of carbon dioxide. Mass of hydrogen is determined by mass of water. Okay. And then the rest is the same. Okay, you find number of mole. And then you divide with the smallest value, which is this value. And then you get 2.4. And again, try and error. 2.4 tak boleh round off. Times dengan 2, tak dapat lagi integer. Times dengan 3, tak dapat lagi integer. Times dengan 4, tak dapat lagi integer. Times dengan 5, baru dapat integer. So, bila awak dapat nilai, kalau kat belakang ni 2, 3, 4, 5 sampai 8, jangan round off lah. Okay, so this is the empirical formula. Okay, next example is also combustion analysis ataupun combustion data. Cerita dia sama. The difference is right here, okay, upon combustion, 0.8233 gram sample of a compound containing only carbon, hydrogen, oxygen. So, this is the mass of the sample. Ni total mass sample tu. Ni adalah mass yang total. Dalam sampel tu, awak ada carbon, awak ada hydrogen dengan awak ada oxygen. So, berat sampel tu adalah 0.8233 gram. Okay, that compound containing carbon, hydrogen dengan oxygen. Okay, so given mass of carbon dioxide, mass of water. Again, same like before. If you want to determine mass of carbon, is from carbon dioxide. 12 divided by 44 times with mass of carbon dioxide. So, dapatlah mass carbon. So, ini adalah mass carbon. Okay, water pun cerita dia sama. Okay, 2 divided by 18 times with mass of water. Okay, dapatlah mass of hydrogen. Okay. And last adalah mass of oxygen. Okay, macam mana nak cari mass of oxygen? Mass total tadi, ni adalah berat total tau, berat sampel tu. Okay, minus with mass carbon, minus with mass hydrogen. Okay, berat total, tolakkan dengan mass carbon, tolakkan dengan mass hydrogen, awak dapatlah mass oxygen. This is the only way to find mass of oxygen. You cannot find mass of oxygen from water. You cannot find mass of oxygen from carbon dioxide. Tak boleh. Mass of oxygen nak cari, ni je cara dia. Total tolak karbon tolak hidrogen dapat mass oksigen. Dia tak semestinya oksigen, soalan boleh bagi nitrogen. Sama je cara dia. Okay. Mass of carbon is determined by carbon dioxide. Mass of hydrogen is determined by water. The rest dia mesti total tolak karbon tolak hidrogen. Dapat something else tu. Okay, yang bawah-bawah ni sama sahaja. Okay, yang bawah-bawah ni sama sahaja. Tak ada perbezaan. Okay.